Now that we can multiply a polynomial by a monomial, let's see how we can multiply any two polynomials. It really just works the same way, except we have to apply the distributive property multiple times instead of just once. Let's start with a simpler case of multiplying two binomials together. Say we have x plus 4 times 2x minus 1. If we use the distributive property to separate the left side, then this becomes x times 2x minus 1 plus 4 times 2x minus 1. Notice how x times 2x minus 1 and 4 times 2x minus 1 are both products of a polynomial and a monomial, which we already know how to do, and they're added together, and we just learned how to add polynomials, so this is something we can evaluate. Using the distributive property again, we see this is equal to 2x squared minus x plus 8x minus 4. And now if we combine the like terms, this is equal to 2x squared plus 7x minus 4. Another way of thinking about this is that we have to multiply every term on the left side by every term on the right side of the product. So if we write x plus 4 times 2x minus 1 here, we need to multiply the first terms on each side, the inner terms, the outer terms, and the last terms. If we do this, we'll get exactly the same terms we got above. The first terms will give us x times 2x, which is 2x squared. The outer terms will be minus x, since we're multiplying x by minus 1. The inner terms will be plus 8x. And then finally, the last terms will give us minus 4. This trick can be used to easily multiply any two binomials. Next, let's look at a visual representation of this to see what's going on more clearly. If we think of x plus 4 and 2x minus 1 as the side lengths of a rectangle, like this, then we can draw this grid to break it down into 4 smaller rectangles. Since x plus 4 and 2x minus 1 are the side lengths of the original rectangle, their product will be the area. But as the diagram shows, the area of the big rectangle is just the sum of the area of these 4 smaller rectangles. And the area of the small rectangles can be calculated easily. Let's look at the upper left one first. Here we have side lengths of 2x and x, so if we multiply them together, we have 2x squared. In the upper right, we have x times minus 1, which gives us minus x. Ignore the fact that this is negative. It won't affect our calculation. And then on the bottom left, we have 4 times 2x, which gives us 8x. And finally, on the bottom right, we have minus 1 times 4, which gives us minus 4. Once again, we get these same 4 terms, but this time it's easier to see where they're coming from. If we add them up, we get 2x squared minus x plus 8x minus 4, which again equals 2x squared plus 7x minus 4. Now everything I've done up to this point has been using binomials, but the same methods apply to arbitrary polynomials. Let's just look at one example to see. Say we have z plus 3 times z squared minus z plus 3. Let's first use the distributive property to break up the z plus 3. This is equal to z times z squared minus z plus 3 plus 3 times z squared minus z plus 3. Now using the distributive property on the first term gives us z cubed minus z squared plus 3z, and then on the second term we'll get 3z squared minus 3z plus 9. Notice that we have a plus 3z and a minus 3z, so these terms will cancel, and then we'll have z cubed plus 2z squared plus 9 left over.